I've spent probably the last 5 years of my life working exclusively designing data centers. So definitely, let's have a look.
I went to Google Images, and because data centers apparently are critical infrastructure, there isn't that many available, but there's this one decent plan
Actually,
that one.
that one looks pretty good. Yeah.
So maybe, I don't know if this is representative of a typical data center, but maybe we can roll with this and see where that
Well,
takes us.
you like data centers really covers a wide range of things, right? You'll have people talk about data center, and it's a large room with 10 racks, and then you have data centers that are 150 megawatt, and now we're talking about the AI data centers. They are talking about a gigawatt plus capacity in a single building, and the specificity of those is something that'll be relevant to the discussion. Is AI data centers are obviously liquid cooled, which I think brings an additional challenge to the Wi-Fi planning. So yeah, we
How does
can,
the
you
liquid
know,
cooling then affect Wi-Fi planning?
well, imagine that, the data center, the infrastructure inside is already pretty dense, and now
Mhm.
you're adding steel pipes full of water or liquid that run everywhere. Can't be
Ah,
good for Wi-Fi.
got it, got it, got it. Okay. So is this something like is this floor plan something you would typically see?
Yeah, that's pretty typical. Uh, quite a, between clients, the way they arrange the building around the data halls and the way they arrange the racks will change. The way they arrange the cable baskets for the telecom optical fiber will change. But overall, it looks like this more or less. Yes.
Very good. And AI modeled it like this. So there's racks, and I think it was just using the default like height for the rack, stuff like
Yep.
that. So we can maybe take a
Well,
look. So these guys are
2 meters.
2 meters high. Is this roughly correct or?
So racks, typical server rack would be, or network rack would be around 2.2, 2.4.
Hmm.
So you're not far off. Um, with the AI deployments, we're starting to talk about up to 2.6 high. So it really depends if you're just traditional cloud computing or
Hmm.
AI computing. It varies between 2.2 to 2.6 essentially.
Got it. Got it. Got it. So this I put them as 2.4. Hope that's okay.
Yeah,
And
it's fine.
the height of the building, what
So
would the
you'd have
height typically
you'd
be?
have to slab about 5 meters, 5 to 6 meters. It depends. Because this you have to imagine you have the racks, and then you have to run all the infrastructure, all the telecom, the electrical infrastructure in between the rack and the ceiling. Usually you'll
Hmm.
have a ceiling. I might expand on that later. I've got a couple of pictures set aside as well, just to all public pictures, so I can show you a little bit how it's built in practice, especially in the hyperscale environment.
Yeah.
And so you'd have all this infrastructure, usually the telecom at the bottom, and then the electrical on top, and then if there's liquid cooling that runs as well in there. So you've got to stack all these layers of services above the racks. So imagine, and you've got to keep separation between them so you can walk on them. So you need between your rack and the ceiling, you need about 2 meters easily.
Mhm.
And then above the ceiling, you'd have services, and you need to use the ceiling as a what we call a air return plenum, so that the warm air from the servers can run back and be, reconditioned as cold air, essentially.
Very cool. So, with that in mind, how would we start going about here? And what other, let's start with this. What other like information, what would be the three key pieces of information you would have asked from your
So
client in
typically, what
addition
can
to this?
impact your propagation here, that's not shown on this, are the hot aisle containment systems. So it will vary depending on the size of the data center, but typically a large data center, hyperscale, or someone like Microsoft or Google will have a hot, we call it a hack, hot aisle containment system. And essentially, every 2 rows, or every 2 rows, you'll have that system. Usually it's like polycarbonate with some structural support, and it encloses the hot side of the servers. So if we look at your image here and we start from the wall, right, that would be a cold aisle. So cold air would blow through that aisle and would be sucked into the servers or the network equipment to cool them, right?
Yeah.
That cold air warms as it goes through the equipment and is rejected at the back of the row, right? So you got your first row, that's a cold aisle, and then this behind that you've got another space in between two server rows, that's a hot aisle. So essentially every rack row goes 2 by 2, right? Because there's a cold aisle, a hot aisle, and a cold aisle, and then you keep going like that. I don't know if this is spaced like that on this plan, but where you have your pointer right now, that would be a hot aisle, right? And in order to be more efficient in terms of cooling the overall room and all the racks, you want that hot air to be contained and to flow up, because hot air flows up, right? And flows up through the ceiling and then goes back to the mechanical plant that's going to recondition it as cold air, essentially. Or if we're in a cold country, it gets pushed out of the data center, and then some mechanical equipment, fans, just push cold air inside, you know. So typically you'd have that system. So it's polycarbonate, so mostly polycarbonate, so maybe not a huge attenuation on Wi-Fi signal. However, you will have structural elements. So you'll have essentially made of unistrut or equivalent aluminum or steel members that are going to maintain those polycarbonate panels, just to block all the possible ways cold air could flow directly inside the hot aisle, because you want the cold air to go through the servers, not around it. So you would essentially seal that as much as possible. And that would be, and if you want, I can share my screen. I can show you how that looks like. You can get that pictures here. Okay. So there's multiple systems here.
Wow.
Resolution, but essentially you've got the server rows here, you've got the telecom infrastructure in yellow and blue, and then you've got the electrical infrastructure at the top, and then you've got the full ceiling. And so on that side, we've got the cold aisle, cold, and then in the middle here, that's the hot aisle. And you can see it's enclosed. So all of these here are enclosed with polycarbonate, and you can see that steel or aluminum structure that's going to hold all the services essentially. So you're going to have all of these blocking your signal. Typically, this is the working aisle. You don't work much in the hot aisle, although that's possible because you've got to plug, power supply to the network switches and so on. You would work in there, but typically you work in a cold aisle. So you want coverage in the cold aisle, but you might want coverage in the hot aisle as well, possibly, right? The liquid cooling I was mentioning are all these pipes here. We can see at the top, and you've got manifolds that connect to the servers, like here at the bottom. So you've got all these pipes that, if you are in a liquid cooling environment, that are going to be full of liquid or water, essentially, purified water, that run through the hot aisle, that are potentially also, something that is going to affect your Wi-Fi signal.
Very
Yeah,
cool. So since that's very, very difficult to model unless we had some kind of beam magic or something like that
yep,
going on, maybe we will just like adjust the RSSI thresholds so that we
yeah,
play it on the safe side because there will be some attenuation, but it's not practical and almost not possible to model it feasibly.
yeah, and maybe just an attenuation area over the hot eye, like
Yeah,
that could be enough
yeah, that
to build
that
that.
could work.
Yeah.
Let's try that.
Or sort of you could have sort of a wall. I don't know if it's going to look like in the software. That might make things difficult to to read, but either that or that attenuation area essentially.
Yeah, yeah, maybe we could do something like that. So we would, let's say we duplicate the server rack, but we do a completely different thing. So what would you say the bottom height and the top height of this attenuation area would be if the rack was 2.4?
I think you could use the same, right? 'Cause do you want to make it higher?
Yeah, I mean depends on
Yeah.
what
So
what
you're
we're.
gonna have those pipes and everything at the top. Like it would go all the way to 4 meters essentially.
Yeah, yeah,
Four point
exactly.
five. Yeah.
Exactly.
Yeah.
And there isn't that much attenuation kind of below the rack level for what I saw in the picture, right?
No, except the rack themselves. No, there's nothing. Yeah.
Exactly. So let's start at the rack level. So assume there's this
Yep.
infrastructure on top of the racks, and then going all the way to the to let's say 4 meters. Okay, and this is the random or like what is
Hack.
it? Random input.
HAC.
What's that?
HAC. HAC. Yep.
There we go. And we slap like, I don't know, 1 dB per meter or something
Yeah.
like
That's
that.
probably it's not enough.
There we go. So we have the HAC there, and then let's see. So you said on the hot aisles, right? And this one was a
Yep.
hot aisle. All
That'd
right.
be one, and then every two essentially. There you go. You're a data center designer. Do you see now?
Woohoo!
Now this one. Nah.
Oh yeah, yeah, I failed. You started complimenting me and I went off the rails, man. There we go. There we go.
I do love that the
Next
tool
one.
just snaps
Yeah.
to the pre-existing
Yeah,
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 that's great. That's
attenuation
that's
areas.
quick.
So
I was
even though
like, are
the
you gonna
AI
copy
does,
paste? It's quicker
yeah,
than copy pasting.
well, I mean,
Yeah,
you can do that, assuming that it's all symmetrical, like one side to the other,
yeah,
or mirror imaged. But it is nice that the I sort of coin it
yeah.
as it does a lot of the heavy lifting, and then yeah,
So
like the
yeah,
built-in snapping that the tool's got can really
yeah,
help. I guess
that's one
any
good thing about data centers is a lot of it is symmetrical. So you could consider copy
yeah.
pasting. Oh, it looks great. It
and then maybe
looks
we
like what
make
I'm
it
working on. That's great.
transparent. There we go. So now it can.
Awesome.
All right, all right.
Um, if we want to push it, to the extreme, these hacks have doors at the end of the row, so you could have a door
Ah,
there.
yeah,
Mm.
yeah. They had some kind of was it some kind of a mesh or something?
No, they're like usually sliding doors. Again, they're made mostly of polycarbonate with like a aluminum or steel structure, essentially.
Okay, so let's do those guys as well.
It'd be
The-
fairly light attenuation, but yeah,
so let's
always tricky when there's metal involved in the
yeah,
materials.
exactly right, exactly right. How do you then deal with that? So door to hot aisle, right?
Yep,
And then we'll say it is metal. And what do we put as the attenuation? Well,
2.5, maybe
two and a
3.
half sounds about right. And then it's all the way to the top of the yeah, it's a
Yep,
2.4. Da, 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 da. Fill top and bottom. Yeah, I think. Oh, hold on. The door was not all the way up, right?
The door goes floor to the top of the rack essentially, so 2.4. Yeah.
Oh, okay. That's perfect then. So let's see what comes out. So this was the hot aisle, right?
Yep.
Now this is where I wish we also had snapping. Whoa, I did make it too high. I think one of the settings was incorrect, which was this guy. Let's check it out again. And this is why you want that. And since I applied the
Yep.
walls, they became non-transparent. So I'll do that as well. Drywall, heavy, whatever. I'll just. And we can modify the exterior walls and everything later.
Yep.
So now
Good.
it's starting
Awesome.
to make more sense. So every hot aisle would have these. I won't do all of these,
Yep.
but
No, no need to, but yeah, essentially.
all right. And then and that's on both ends of the hot aisle, right?
Exactly, yeah.
There we go. Okay, now that we have this laid down, what's the next step?
Well, the rest is going to be very tricky to model, right? So
Yeah. Do we
what I've
just
seen,
start firing up APs and see kind of?
yeah, let's have a look. So typically what I've seen is you've got APs deployed on the main aisles, so the top and bottom corridors. One thing that's important is that usually these are called moving aisles, so you got to be able to roll in servers. And while the servers are 2.4, usually rolled in on some, I don't know, they call them that, like they've got like some sort of vehicle that pushes them in. So you need about 3.2 meter clearance, let's say 3 meter clearance from floor to ceiling.
Mm-hmm.
So the AP shouldn't be in that zone. So it's usually a little bit higher than 3 meters. It's usually installed under a cable basket and just sits there essentially, which means usually it's not always at the correct height to, to provide coverage in the eye. So sometimes we have to install APs in the cold aisles. And
Okay.
if deemed necessary by the data center operations, we can also put them in the hot aisles. But I'd be keen to see what the coverage result will be in the hot aisle.
Okay, and which now you have the luxury of choice. What would be your weapon of choice? What do you typically use?
Everything between Cisco, Aruba. I'd be keen to use a Mist AP if you have them. Yeah, I always like Mist.
Okay, which model would we go with?
Juniper now, sorry. I'm old school.
Now HPE.
HPE, Juniper, Mist. Yeah, can't
Exactly.
keep track of it.
Through a couple of acquisitions, which would it be 45 that we'd be deploying here? Nowadays, I guess 47.
Yeah, anything really. Like, you're not worried about density in a data center. It's really coverage.
Okay, so that a good solid omnidirectional Wi-Fi 7 AP. And you said
Exactly.
a few meters off the ground. So
Yeah, it depends where you deploy it. If you deploy it on the perimeter, it'd be 3 meters. If you deploy it in a cold aisle, it really depends.
yeah.
They'd be, let's say, we can aim for 3 meters. Yeah.
Okay. And where would you start?
Well, like I said, you want coverage in the cold aisles. That's where you do most of the work, right?
That's where we
So you
start. And you say that the ends, what was it so or?
It's probably easier at the end because you gotta be able to roll in racks in those, whether you alternate rows. We can see what I see is that, you know, the hot aisle is not really covered, right?
Yeah. So do we put?
So whether you alternate, put one in the middle,
Oh, yeah.
I think you could alternate rows with one in the middle, and
Yeah,
essentially
man.
that should work. Yeah,
And kind of continue on like that, right? So
essentially, yeah.
one here, couple here, one
So that's good.
here, couple here, and one here. Of course, yeah, now it's not completely symmetrical, but good, close enough. Okay. So at least for 5 gig, that gave us pretty good primary coverage. Did I place them at the right height and stuff? I guess I did.
Looks like it, yeah.
And what's the critical height that we'll be looking at for the coverage?
Typically, it's just technicians working, on an iPad. So
Okay, so 1 meter
1
would be
meter is
good.
fine.
Is there
Yeah.
anything at the top, for example, that we should be concerned about or anything like that?
Not really. You could have sensors, but usually they're wired in the data hall.
Yeah.
You could have sensors at the top of the row sometimes, and I'm sure that will become more and more common. Typically now they're wired, but there are some sensors that exist that are wireless. So
Very
you
good.
could have a requirement for coverage at the top of the row, just above the row.
What metrics would you be looking at? Primary and secondary coverage, I guess, are the
Primary, secondary, they can be location services to track technicians and assets. In which case, well, you're on secondary. So I've seen clients deploy 2 APs per or every second call die. So whether it's for location services or roaming, can't really say, but yeah, like
something like
obviously,
this to at least
yep,
for secondary coverage, we would now the secondary coverage is starting to look a lot better.
exactly, yeah.
And for location services, what would be the use case for location services here?
It would be really, you're sending a technician to work on a server, and they're like, oh, well, they're calling back up the ops center, like, am I in the correct row? Where am I going? I just walk a further 10 meters or something like that. So in saying that, if you're given a row number and a rack number, you should be able to find it. But some of these places are absolutely huge. So, and everything looks the same, right? So,
Got it.
yeah.
So it would be Wi-Fi based location services. How would it work? Over BLE, Wi-Fi? What would be the tracked device?
Like, I'm not a big fan of Wi-Fi based location services, so I'd much rather go with a Bluetooth based system.
Yeah.
Obviously, you could go with the Cisco angle of arrival or anything like that, right? And just do some triangulation.
Okay.
I'm pretty partial to the Bluetooth method. Yeah, it really depends.
Yeah. Got it.
Like, it's pretty good. Like, it's
Which
not.
is BLE tertiary,
Yeah,
right?
yep.
Yeah, it's not
You
bad at
could get
all.
away with that.
Okay. Excellent.
Yeah.
And what would happen next? Is this kind of how the cookie crumbles then, and then you repeat this? Any other considerations?
Yep. Well, that's the data hole, right? That's just only one part of the data center. You've got to think about all the other areas as well. Obviously, the admin area is pretty easy. I don't think there's a big challenge designing for that. But you've got all the plant rooms, essentially electrical rooms, mechanical rooms, and it's pretty heavy equipment. you know,
Yeah.
big metallic cupboards full of copper, essentially.
Yeah.
So
Yeah.
I find
there.
that when a client wants full coverage, they tend to underdo the Wi-Fi deployment in those rooms. This would be for the fire system in that room. Again, big plants, metal, steel, pipes full of water, everything Wi-Fi loves, right? So
Yeah.
you kind of have to overdo the Wi-Fi deployment in those spaces, and there's also outside, right?
Yeah.
So there's a lot of external plant in those buildings. Probably not as evident here, although yeah, we can see on the left here some generators. Uh, and
Yeah.
a generator essentially is like a big container full of steel and diesel, right? So again, that's gonna pretty much stop your signal straight on. And again, that's pretty often not well covered. What tends to happen is access points are deployed on the external walls,
Yeah.
and
So this
you
would
know,
be outdoor area. At least that's what AI
yep,
predicted it to be.
yep. This is all outdoor. You've got a loading dock on the right
So we
for equipment delivery.
could go 63s, for
Yep,
example, at 3 meters height or
yep.
something like that on the
Mm-hmm.
wall, and then just blast away. I'll just create a scope zone so that I'll just accept that indoor scope zone first, and then I want to see also, I want to include this guy into the coverage as well. But like you said, there is these massive, elements
So
that the tool the AI did not pick up, so we will need to model.
it's not surprising. It's pretty specialized, right? So I don't blame the AI for not recognizing that.
Yeah. So we would just take.
Yeah, we'd use like the attenuation is going to be pretty high. Like
Yeah.
these are essentially big electrical cupboards or containers that are full of stuff.
Yeah. And these would
Yeah,
be a
between
couple of
3 and 4.
meters high or
Yeah,
something.
it can be up to 4 meters high. 3 meters definitely.
We'll play it safe and not say not even transparent. So like these guys, what a massive difference in coverage it makes.
Exactly. Yeah.
So actually the wall, even the APs on the walls may not actually cut it.
So you can see even those, obviously
Yeah. So
those
let's.
big generators. That's what's going to, and even those transformers. Essentially, they are smaller, but they're also very dense. Right?
I'll just play it safe. We could change the transformers to something maybe. Are they lower than the rest of the stuff?
It's hard to say. I think it's going to pretty much stop the signal dead, right?
I'll just use that.
Does Hamina account for signal reflection or?
It does. It does
Yep.
if we tell it to. So let's take a look at that too. Because
I
in
think
here
that's
you
where
want those.
yeah,
You definitely want the reflections to play to your benefit. So let's place a few
definitely.
of these 63s first. No reflections. So just set this up here. Pow, pow. Try to shoot between those things.
Yeah, you can try.
All right. Here by the door and one more here. So this is how it looks without reflection, and I'll just turn off the channels. You should probably turn off the channels by default nowadays to, to make it cleaner. But okay, so without reflections, let's calculate reflections. This may take some time because it has a lot of shelves and everything on the system.
Oh, wow. Didn't know you had that in there. That's great.
Yeah, this is on the Pro version, I think. The standard planner does not have it, but the Pro does. So it simulates the effect of reflections, refractions, and diffractions.
Wow.
And it's 3D, so it's not just in a two-dimensional space or anything.
It's
So okay, now
really
it's
good.
filling them in, and we can see,
Yeah.
it made
Yeah.
quite a bit of a difference. I would say this environment probably is actually more reflective than that, which we can control here. So
Okay.
let's actually put that to, of course, these are probably metal, right? So it is the most
Yep.
reflective case type of a thing. Recalculate that with that.
Yeah, that's really good. Because otherwise, yeah, you'd have to overdo it with the access points if you just base it on what we're seeing on the screen, right? And it can get tricky because we cannot use those big boxes, can't install equipment on that.
Yep.
So we'd have to deploy poles. There would be poles, there would be lighting poles outside that we can use, but it makes things obviously a lot more complex and more expensive.
Yeah. So with maximal reflections, this is the best case in a very reflective environment. I would say it's like this is just based on experience surveying and stuff like that, but maybe number 4, like maybe somewhere in between. It may not be perfect, like right behind the transformers and stuff like that, but I would expect this to be okay for the most part. What do you think?
Well, if a technician has to walk 5 meters or 2 meters to have good signal, it's not the end of the world. Rather than having to run a conduit all the way around, because typically you won't be able to run a conduit underneath these transformers or generators.
Yeah.
Because there's electrical trenches with high voltage cables running there. So you'd have to go all the way around this fiber and use either extenders or media converters, and it becomes tricky to consider and deploy, and obviously more expensive. So if you can avoid having to deploy those poles, and you can prove that you can avoid it, that's definitely great.
Yeah, absolutely. Well, it's starting to look pretty good.
Yeah. Well, that's it. You're a data center designer now.
It's a long way to go. Do you ever have to account for cabling yourself or things like that?
I don't really do it. And unfortunately, I don't have measurements, any attenuation measurements within the data center, so I can't really say if it's really necessary or not. I think between, what we've done in the data hall to start with, between that and taking account the reflections and all of that, I think, it's probably enough.
Yeah.
The other thing to account for, obviously, is more and more now, especially in Asia Pacific, we're seeing multi-story data centers. So the floor-to-floor attenuation, as you can imagine, is going to be pretty high.
True.
Because you have not only you have that full ceiling, you have all these services running, but also you have pretty strong slabs, because that's very heavy equipment that's installed on those floors.
Yeah.
So you're gonna have which to your benefit, right? You want a strong floor-to-floor isolation from the RF point of view. So
True.
definitely you shouldn't count on signal bleed from over floor. It's not going to help you.
Yeah, it's just and that's where kind of the full building 3D that we're about to publish as well becomes handy.
Definitely.
Yeah, I just started driving around the roaming man and kind of seeing how the client would behave here as the technician goes. Let's say as he goes even to the hot aisle, and so
Yeah,
here,
that's
of course, the APs have to like you know, it just picks up whatever it picks up. There's no AP on the
yeah,
aisle,
it picks up like it's pretty
but it
good.
still seems quite good. Even when it's roaming, it doesn't like. It never reaches terrible coverage, things like that. It stays pretty solid, actually. Yeah, thank you,
Yeah,
Eric.
that's great.
This was super handy.